Alright, so another question I really like to ask on an exam is how can we decrease the width of confidence intervals? So we discussed in class, and I know in the Tuesday class Zach mentioned, as an interpretation of the CNN poll, that we weren't really sure whether or not the actual measure would pass or fail, right? Both of those were possibilities. So theoretically, CNN would want to decrease the width of that confidence interval and have higher accuracy. So how could they accomplish that? So there's two ways they could do it. First off, if we want to decrease the width, one thing to remember is that the way our confidence interval is created is by taking our estimate, right, our p-hat, and adding or subtracting a margin of error. So that margin of error, you kind of visualize your interval this way. You start with a p-hat, you add a margin of error, and you subtract a margin of error. So the width is directly related to this margin of error. So we want to bring down this piece, our critical value times our standard error. We want this to be lessened. So you can think of it more mechanically like this in terms of what actually would change in this calculation, or you can kind of use some of the intuitive stuff that we did during class to get there. So the first thing that we could do is we could decrease the confidence level. We saw this in the example about guessing the proportion of Hispanic students at Mesa, where basically this is sometimes counterintuitive what students expect, because a small interval is better, so they think of that as being less confident. Alright, I forgot what I was saying, but so what we had in that example with Hispanic students was that if we increased our confidence interval, we actually increased our confidence level. We had a larger interval because we want to be more confident about catching that true value. So our confidence intervals are about this trade-off between accuracy, which is decreasing our width, and confidence. So these two things sort of move in the opposite directions in terms of more accurate, smaller width, less confidence, more confidence, less accuracy, larger width. And you can also see that because the confidence level, it has directly influences our Z star, and if we went to that table with all the Z stars on it, we can see as our confidence levels go down, our Z stars also go down, and we're directly multiplying by that critical value. So multiplying by a smaller number will result in a smaller margin of error. So decrease the confidence level. Now the size of the sample, we've already seen this also conceptually in sort of the questions we were chatting about, right? When we were talking about the percent of left-handed or proportion of left-handed students, we said we felt the strongest, or we felt the best about the sample of 1,000 students. The more students we had, the closer we should be to the real value, whether we're thinking of this as part of like the law of large numbers, or if we're thinking about the actual standard deviation of that sampling distribution that's going on behind the scenes, or just sort of intuitively, the more people I have, the more accurate my estimate's going to be. And then we can also see that again in our formula, because our n is here, and the larger this value is, if we divide by a larger number, we're going to decrease this margin of error as well. So always love to have a question on there about how changing up these pieces of our formula or of our sample or our confidence interval will change our confidence interval.